Hey guys, today we're going to talk about how to write quadratics in standard form when given either points or a table representing the quadratic. So, you need a lot of room today. So the first question that we have, we are asked to write the equation of the parabola that goes through the 3 points, and the 3 points are -2, -1, 0, -5, and 2, 7. And we want to write the equation of the quadratic, and we'll do this in standard form. So we want to write it in y equals ax squared plus bx plus c. That'll be our goal here. Now, if you look in standard form, if you think about a, b, and c, those are our missings here. We need to find those 3 values. A is our leading coefficient, and if you think about C here at the end, that's actually our y-intercept in standard form. If you look at your 3 points, we're actually given the y-intercept. So what's nice about this one is ax squared plus bx. We know the y-intercept, or the C value, is -5, so we can substitute that right in. But now we still run into a bit of a problem because we don't know what A and B are. But we have these 3 points. We know the parabola is going to go through those 3. So what we can do is we can take our values. Remember, every ordered pair is x comma y, which means when the input of x goes into the function, the output is going to be y. And we can use this. Meaning, let's say, I'll take this away. Let's say we go to this point down here. When the value of x is put into this function, y is going to be 7. So I'm just going to substitute that in because I know that. So y is going to be 7, so 7 for y, when x is 2. So I'm going to leave the a as a. We don't know what it is, but we know when x is 2, y is 7. There's also an x right after the b, though, so b times 2. And again, we know that c at the end is -5. So we can just simplify this. 7 equals 2 squared is 4, so it's a times 4, which I'm just going to write as 4a. b times 2 is 2b, and we have the -5. Now I'm going to bring the 5 over to the other side, so we have 12 equals 4a plus 2b. Divide everything by 2, so we're going to have 6 equals 2a plus b. And there's really nothing else that we can do with this one yet, but this is an equation that we can use. And we use the last point to make that equation. Now I'm going to use this equation up here, or this point up here, to make a different equation. So when y is -1, x is -2. So when you have -1 for y, I'm going to go ahead and replace all the x's with -2, plus b times -2, and we know the c is -5 still. We know that's going to happen. And now let's just simplify. -1 equals -2 squared is 4, so 4a. b times -2 is -2b, so -2b, and we have the -5. So let's add that 5 over to this side. When you add the 5, you get 4 equals 4a minus 2b. We can divide everything by 2, so 2 equals 2a minus b. And then all we have to do now is take these 2 equations, right here and right here, and we have a system of equations. So I'm going to drag this one up with us. We'll have 2 equals 2a minus b. We have these 2 equations. They make up a system together. And we can use elimination here if we want to. If we add, we'll cancel out the b's. So 6 plus 2 is 8. 2a plus 2a equals 4a. Negative b and positive b, when you add them together, go away. So you can divide and find out that a is equal to 2. Then if we go back to our system and put a 2 in for a, let's say we go to this first equation, 6 is equal to 2 times 2 is 4. So 4 plus b will give us 6, meaning b has to be 2 as well. So we know a is 2, b is 2. We already knew c was -5. So we go back to our equation, y equals, now we know a is 2, so it's 2x squared. We know b is 2, so it's plus 2x, and -5. This is the equation of the parabola that goes through these 3 points. A little bit of work, but it's really awesome to get this in the end. All right, our next question, we have a table. So our table looks like this. We have X and Y. We have 0, 1, 2, 3, 4. And we know 5, 8, 17, 32, and 53. And we're told that this is a quadratic function, and we want to write the equation in standard form for this function. So we want to be in y equals ax squared plus bx plus c. Now if we look at this table a little further, you might notice again we are given a y-intercept, 0, -5. That would be our c value here. So we're going to end up with 0, +5. So we're going to end up with a +5 at the end. If you didn't recognize that, you could substitute values in for x. 0 and 0 equals 5, and you're going to find out c is 5 anyway. So we have a +5 at the end. Now we have 4 points that we can choose from, and we're going to do the same thing that we just did with the other problem. We're going to substitute in our x values and our y values, the ones that correspond together. I'm going to use the smaller values because it makes it a little bit easier. So let's say x is 1 when y is 8. So in the equation, when y is 8, so 8 in for y, x is going to be 1. So a times 1 squared plus b times 1 plus the 5. I'm going to bring the 5 over, subtract the 5 from both sides. So you get 3. 1 squared is 1. So a times 1 is a. B times 1 is b. So here's an equation. 3 equals a plus b. Now we also need another equation. So this equation was made by these 2 points, that like ordered pair that goes together. Now I'll use these 2 points to make another equation. Y is 17 when x is 2. So I'm going to put a 17 in for y and a 2 in for all the x's that I see. Let's bring that 5 over. So you have 12 equals 2 squared is 4. 4 times a is 4a. 2 times b is 2b. So we have a nice equation here. We can divide everything by 2, which is nice. So 12 divided by 2 is 6. 4 divided by 2 is 2a. And 2 over here divided by 2 will give us a coefficient of 1. So we have just b. And there's our second equation. So these 2 equations right here, they make a nice system. A plus b equals 3. And 2a plus b equals 6. I would do the second equation minus the first equation. And when you do this, 2a minus a gives you a. B minus b cancels out. 6 minus 3 gives you 3. So a is equal to 3. And then I would go back to this over here. If a is 3, 3 plus b equals 3. So therefore b must be 0. Which means we can go all the way back up here. A equals 3, so y equals 3x squared. B is 0, plus 0x, plus 5. We're not going to write the 0x, so that term's going to go away. So our final equation is y equals 3x squared plus 5. That middle term has a coefficient of 0, so we're not going to write it. And there you go, there's your equation for your second one. We're going to do one more, and then you can try some of these on your own. Our next one's going to be a little more involved, and we're going to see why. So our next one, we want to write the equation of a parabola that goes through these points. -4, 3. -1, -6. And 3, 10. So for this one, it's a little bit different because we're not given the y-intercept here. We're not given that c value. So we're going to have to do a little bit more work. And it's all about staying organized with your work. But we're going to go through the same process. Remember, these are still ordered pairs. So it's still x comma y, meaning an x value that corresponds goes with the y value, an input and an output that go together. So if we look at the first point, the -4, 3, that means, and again, we're going to want to end like this, y equals ax squared plus bx plus c. That means when y is 3, x is -4. So when y is 3, x is going to be -4. So we're going to have a times negative 4 squared plus b times negative 4. The only difference here is now we don't know what that c is at the end, so we're just going to write plus c. We can simplify this whole thing right here. We end up with 3 equals negative 4 squared is 16a minus 4b plus c. That was for our blue point here. Now let's see what happens. We'll do this one in blue to color code. When y is negative 6, so when y is negative 6, x is negative 1, so it's a times negative 1 squared plus b times negative 1 plus c. So negative 6 equals negative 1 squared is positive 1, so it becomes a. B times negative 1 is minus b plus c. So now we have a second equation. And we'll do this one in red to work for it. When y is 10, x is 3. So 3 squared plus b times 3 plus c. So 10 is equal to, and we're going to have 9a when you simplify, plus 3b plus c. There's a lot going on here, so I'm going to use green and kind of mark off the equations we're going to use. Actually I'll box them off. This equation here, we simplified. This equation was one we simplified, and this one down here. So we have 3 equations, 3 variables, and we can even go a step further, and we can label those equations if we want. We'll call this M, N, and O just to stay organized. So let's look at M and N. Notice how they both have a plus c, so we can cancel that out. So I'm going to do equation M minus equation N. So if we do that, we would do 3 minus negative 6, which would give us a 9. We would do 16 minus 1, so we'd end up with 15 a's. We would do negative 4 minus negative 1, so it's like negative 4 plus 1, which is minus 3 b's. And c minus c is going to get us 0. So when we do equation M minus N, we end up here. And we can simplify by dividing by 3. So 3 equals 5a minus b. So this will be a big equation to use. Now we've eliminated c's. And if you look at these two equations, we can do the same type of a thing here. We can try to get rid of the c's. And looking at them, I would want to do O minus N. So 10 minus negative 6 is 16. 9a minus a is 8a. 3b minus negative b is like 3b plus b, which is plus 4b. And c minus c is going to give us 0 c's. We can simplify this by dividing by 4. So 4 equals 2a plus b. And now we have a nice little system here. So I'm going to rewrite our system. 5a minus b is equal to 3. That's our top equation. Our bottom is 2a plus b is equal to 4. Notice with this system, if you add the equations, the b's will cancel. So 5a plus 2a is 7a. 3 plus 4 is 7. The negative b plus b cancels. So here we're going to find out a is equal to, that is a 1 down here. If a is equal to 1, you can go to either one of these two equations. Let's say we go to the second one, and you're going to have 2 plus b equals 4, which means b should be equal to 2 here. And let's see, so we have a is equal to 1, so we have x squared, plus b is equal to 2, so plus 2x. We need to figure out c. Once you have a and b, you can go back to any one of these 3 equations to figure out c. And I'm going to take equation n up here. Negative 6 equals 1 minus 2 plus c. 1 minus 2 is negative 1. So therefore c is going to be negative 5. And we can go ahead and put that minus 5 here. So this is the equation of the parabola that goes through these 3 points. A lot of work. It's about staying organized and keeping everything in track, knowing what you're doing. This system was a little more complicated. Alright, so if you want to go ahead and try some of these on your own, you can. I have 3 more in the slide presentation, so if you want to try those on your own, I'll continue here and show the work for those three. If you want to move on to just trying some on your own outside of this video, you can do that as well. But if you want to stay, I'll do those three in the last slide, and you can check your work with me. So if you're leaving now, have a nice day. If you're staying, we'll have more fun. Alright, so we have the table. For the first one, we'll do the blue one, top left. We have -4, 1, 0, 9, and 1, 16. So this is a quadratic, and we're trying to make the equation in standard form. We want to find the parabola that's going to go through these 3 points. So if you look at the table, you might notice our c is given to us, ax squared plus bx. The c is actually going to be 9 here. So we're going to have a plus 9 for this one. And now we can do a little bit of substituting. So I like color coding, so I'm going to take this first point over here. That's like the ordered pair, -4, 1. When x is -4, y is 1. So y is 1. When x is -4, it's going to be -4 squared. So I'm going to skip right to having 16a here. And then you're going to have minus 4b. And you have the plus c, which we know is 9 here. I'm just substituting as I go. -4 squared gets you the positive 16, and you'd have -4 in front of the b here. Bring your 9 over, so you have -8 equals 16a minus 4b. Divide everything by, looks like a 4 here. So -2 equals 4a minus b. And there's our equation. Now let's go green. So if we look at the green here, when x is 1, y is 16. So when y is 16, x would be 1. So ax squared would be a times 1, which is a, plus b, plus our 9. So bring the 9 over, and you're going to end up with 7 equals a plus b as our second equation here. So let's make this system. I'll rewrite it nice and neat. 4a minus b is equal to -2. A plus b is equal to 7. This is a system. We can use elimination, add the equations together. You get 5a, -b plus b goes away. -2 plus 7 equals 5. So you get a is equal to 1. That's nice. And now you just need to find b. I would use this second equation. 1 plus b equals 7, so therefore b is equal to 6. And you can substitute in. A is 1, so it's x squared, plus b is 6, so 6x. And we already knew c was 9 because we were given the y-intercept. So there's our equation for the parabola through these 3 points. Let's move on to the green one over here. All right, our green one. We have the table. X and y values are inputs and outputs. 0, 1, 1, -1, 3, and 7. So for this one, again, we are given the y-intercept, which is nice for us. We know what c is. C should be 1. So we're going to have y equals ax squared plus bx plus 1. And now let's do a little substitute and help find a and b. We'll take this first point here. It's like the point, the ordered pair -1, or 1, -1. So when y is -1, x is going to be +1. So ax squared would end up being a plus b, because it's b times 1. And you're going to have a plus 1 at the end. Bring your 1 over, you have -2 equals a plus b. Now let's look at our other point here. Y is equal to 7 when x is equal to 3. So we're going to have ax squared is going to be 9x after you simplify, plus 3b, and then we're going to have a plus 1 at the end. Bring your 1 over, so subtract your 1. You're going to have 6 equals 9a plus 3b. You can divide everything here by 3. So you'll have 2 is equal to 3a plus b. And then you are ready to do a little bit of elimination. So let's go with green. We have a plus b is equal to -2. Then we have 3a plus b is equal to +2. Let's do the second equation minus the first equation. So 3a minus a is 2a, b minus b is 0, 2 minus -2 is +4, so a should equal 2. And then we can substitute back in to find b. We'll use this top equation. 2 plus b equals -2, so you could subtract 2 from both sides, and b is equal to -4. So when we substitute in, we have 2x squared minus 4x plus 1. This is our equation for the parabola through these 3 points. Alright, on to our last problem on the video. Our last problem, we have a nice little table with x and y. We have -1, 2, 1, 4, and 3, -18. Alright, so looking at this table, we don't have the y-intercept given to us. So we're going to have to do a little bit of work, a little bit more work. We don't know a, b, or c. None of those are given to us. So let's go ahead, and I'm going to color code these. We're going to take the point -1, 2. That's going to be this first one, and we're just going to substitute it in and simplify as far as we can. So y is 2 when x is -1, so it would become just a, because -1 squared is 1. You're going to end up with a minus b and a plus c. That's what happens when you input this input and output into the function. Our next is going to be this middle point here. That's going to be the 1, 4. So for the 1, 4, that means y is equal to 4. And x is 1, so it's going to end up being 1 squared is 1. 1 times b is b. And you're going to have the plus c at the end. And let's see if we can squeeze this last one in. We're going to have 3 and -18 here. So y is -18. X is going to be 3. So 3 squared is 9. So it'll be 9a plus 3b plus c. It just barely doesn't make it. Alright. So let's look at, move this over a little bit, plus 3b plus c. That looks better. So these are your 3 equations, and I'm actually going to rewrite them so we can see if anything works out for us. We have a minus b plus c is equal to 2. We have a plus b plus c is equal to 4. And we have 9a plus 3b plus c is equal to -18. And this is our system, 3 equations, 3 variables. If you look at the first 2 equations, notice how they both have a positive a and a positive c. That's a great sign because we can cancel 2 variables at once. Let's label these. We'll call it g, f, and h. Sure. If we were to do equation f minus g, you would do a minus a, which cancels out, b minus -b, which is 2b, c minus c, which cancels out, and 4 minus 2, which is 2. You can solve for b, and b is 1, just like that. Really quick. Now we can go ahead, now that we know b is 1, that means we could substitute b in for, or 1 in for b. Like if I take equation f here, and I put a 1 in for b, I'm going to end up with a plus 1 plus c equals 4. So a plus c equals 3. This is my new equation f. And if I were to take equation, let's do equation h, and we put a 1 in for b, you're going to have 9a plus 3 times 1 is 3, plus c equals -18. You can bring the 3 over. You're going to have 9a plus c is equal to -21. This is my new equation h. Since we knew the value of b, we can substitute them in. And now we can set up elimination with these 2. So I'm going to rewrite them over here. A plus C equals 3. 9a, actually I'm going to go above. 9a plus c is equal to negative 21. And I'm going to do equation 1, or actually equation h minus equation f. So top minus the bottom. 9 minus a is 8a. C minus c is 0. Negative 21 minus 3 is negative 24. And when we divide by 8, we're going to find out 24 divided by 8 is negative 3. So a is negative 3. B is equal to 1. If a is negative 3, I would just go right here. Negative 3 plus c equals 3. So therefore, c is equal to 6. Don't know if that's going to fit on there or not. So we have all the values that we need. So they're all going to come together now. A is negative 3. So y equals negative 3 x squared. B is 1. So plus 1x. C is 6. So plus 6. And just like that, we've figured out the problem. And that is awesome. So that's the equation of the parabola that's going to go through these 3 points. A lot of work, all about staying organized and keeping on track, but I think it's really fun. Alright, so have a nice day, guys. Try some of these on your own. Hopefully you're feeling confident with this.